Hi rock buddies, it's Papa. Hope you guys are doing well. It's a beautiful spring day and I can hear a cardinal calling out here at the Minimalist Cottage. But today we're going to talk about the geologic history of the eastern United States, and specifically in this video we're going to talk about the Rifting of Rodinia and the Cambrian explosion of life. I realized I couldn't do this whole geologic history in one video, so I'm going to break it up into at least 3 videos, and this is the first one. So I hope this will be helpful and useful to you. If it is, please subscribe, because as you know, this helps me immensely, and I appreciate it very much for all those folks who have subscribed to me. So the geologic history of the eastern United States, the Rifting of Rodinia, and the Cambrian explosion. Here we go. I'm going to start this off by giving an overview with pictures from this book called The Rocks of Georgia, which is my book, and you can get it on Amazon Books. So there's no copyright infringement here. And after that, we'll get into more detail. We'll tell the same story, but it'll just be in more detail. So here we have the supercontinent Rodinia as it existed about 1 billion years ago. We have Laurentia on the left, which is basically plus or minus the eastern United States, Africa on the right, and the eastern United States is totally landlocked in the middle of Rodinia. Remember, a supercontinent is a continent that contains all the land on the whole Earth in one big giant continent. And supercontinents always rift apart. Why? Because that huge landmass acts like a lid on a hot pot of boiling water, and it just makes the hot pot and the water even hotter, and that causes convection currents in the mantle that end up busting that supercontinent apart. And that is exactly what's happening in this picture. You can see the mantle hotspot. It's burning a hole in the supercontinent Rodinia and busting it up into several smaller continents, just like we have today. This picture on the right, we have a rift valley that will soon become an ocean, and that will be the main rift. On the left, we have half grabens or half drift basins that were not part of the successful rift, but did drop down and received tons and tons of sediments. And in this picture, you have the ocean forming on the right. And on the left, you have the half grabens with the rift sediments. But in the middle, you have a hunk of Laurentia, or the eastern United States, that has completely rifted off and drifted out into the ocean. A rifted hunk is what I call it, of basement rock. It does not show up in this picture, but on either side of the rifted hunk, sediments accumulated after Rodinia rifted. These are called post-rift passive margin sediments. And in this final picture, we have the pink Cambrian explosion rift to drift sediments. And by the way, this picture also shows the brown passive margin, post-rift passive margin sediments that were missing in the last image. Okay guys, now let's get into more detail about the rifting of Rodinia supercontinent. Okay, back to the rifting of the supercontinent Rodinia. Here is a tremendous Crayola crayon drawing. First of all, here's ancient Africa that is just rifted away from ancient North America. This is the developing mid-ocean ridge, bunch of volcanoes here that are producing basalt lava that is becoming ocean crust on each side of the rift, and it's making the ocean bigger both ways. Okay, so this color, this orangey color, represents the old granite and granite gneiss basement rock of Rodinia. What Rodinia was made out of. That would be this part of this side view. Bird's eye view or overhead view, side view. So the orange represents the old Rodinia land crust, or basement we call it. It's mostly granite and granite gneiss. Now what has happened is, in this picture here, the side view, you can see this is some more land crust basement that's rifted off of the mainland and drifted out into the ocean. That would be this, from the overhead view, this part. This is the what I call the rifted hunk of basement. Okay. Not only that, we have these partial rift basins that did not end up in the rift, because the rift is way over here, right here. These partial rift basins contain rift sediments. First they rifted apart, but not all the way. You could call them half rift basins. And they filled up with sediments. The best place to see these sediments that I know of is Great Smoky Mountains National Park, which is right in here on the North Carolina-Tennessee border. There are also rift basins, Rodinia rift basins, all up and down. And of course, we are talking about what happened from Maryland down to Georgia. We'll deal with this northern part later. Okay, what is this orange? This is rift volcanics, volcanoes that actually did the rifting. This would be diabase, magma, and basalt lava eruptions. Also felsic lava, rhyolite, which would have erupted and actually did the rifting. It did a much better job here where the main rift is. But here, there was some volcanic activity associated with these partial rifts that ended up not being the main rift. So where do you see these volcanics? Here's on the overhead view, it's this red Crayola streak. And if you want to see these rift volcanics, this igneous volcanic, the remnants of it, you can go to Mount Rogers in southwestern Virginia, and you can see rhyolite, which is a very silicon-rich felsic lava that erupted during the Rifting of Rodinia. And if you go up to Shenandoah National Park in northern Virginia, you can see the Catoctin Formation, which was once huge amounts of basalt lava that flowed out in the process of the Rifting of Rodinia. Okay, not only did you get a rifted hunk, igneous volcano activity, rift basin sediments, you also got what we call passive margin sediments that eroded off the land right after the rifting, and that would be this purple stuff, post-rift sediments. Here we go. Here on both sides of the rifted hunk. And these things have various names. Down in here in Georgia, we call it the Murphy Marble Belt and the Dahlonega Gold Belt sediments. In North Carolina and South Carolina, they're called the Alligator Back Formation. And up in Maryland and Virginia, I believe they're called the Westminster Formation. Now, the post-rift passive margin sediments that developed out here on the ocean side of the rifted hunk have names too. And I'm pretty sure I'm right about the names for both of these areas, but any geologist who knows differently, I'd love to hear from you. Down in Georgia, we call the ones on this side, we call the sediments the Tallulah Falls Formation. Up in here, North Carolina, South Carolina, we call them the Ash Formation. And from Virginia to Maryland, they're called the Potomac Formation. But they're all the same things, as I said before. Post-rifting passive margin sediments. As the mainland and the rifted hunk eroded into the ocean on both sides. On this side, we have mostly sandstone and shales. On this side, we have what we call grabens or metagraywacke, and that's a silt mud base that has hunks of quartz and feldspar in it, all mixed up. We also have black shale over in here, like the Chattanooga shale, but Chattanooga shale was not part of this. Okay, and finally we have, after Rodinia rifted apart, it began to, the continent pieces began to sink, their edges sank, which always happens after a rift. And that's when we got what we call rift to drift sediments deposited. Rift to drift. And that's represented by this yellow that's all over the place, all over the whole United States actually, except maybe a little bit from New Mexico to Minnesota, where there were some islands that stuck up above the water. What happened was, first you get a layer of sand. As the ocean rises, the sand beaches migrate uphill. And then the mud that's out in between the mainland and the barrier islands also migrates uphill, and it covers the sand. And then the seashells and very lime-rich mud rises up and covers the mud itself, the silt and mud. And so you get a layer that has, and that would be here, that has sand at the bottom, equals sandstone, mud and silt on top of that, which equals shale, and then limey mud on top of that, which equals limestone. And so that was represented by all the shallow material. And during that time, the rift to drift time, virtually the whole world was in a very shallow, warm sea. And the cool thing about rift to drift was that was also the time of the tremendous Cambrian explosion of life, which you have probably heard of. And that was between 550 million years ago and 500 million years ago, right after the rifting occurred. The rifting of Rodinia occurred between 750 million years ago and 550 million years ago. So the hardest part for me is to remember the things that happened associated with the rift basins and the rifted hunks. So I'm going to tell you a way that I remember it. Rift has 4 letters, R-I-F-T. For the R in rift, that would be rift basins, like the basins at Great Smoky Mountains National Park and all up in here too. I of rift is igneous volcanoes that did the rifting, and that would be these igneous volcanoes in here, like Mount Rogers and the Catoctin Formation of Virginia. F for me means far out rifted hunk of basement, far out rifted hunk of basement. And T means tons of sediments deposited. So R-I-F-T. Rift basins are igneous volcanics I, far out rifted hunk F, and tons of sediments T. If you can remember those major things that are associated with the rifting of Rodinia, then it's easy for me to remember rift to drift and the sand, mud, and limestone layers that covered the world. Now this rifting process happened everywhere on Earth, the same sequence. And even though I haven't drawn it down in here and up in here, it happened just the same way, all up and down the eastern United States. Probably down in here too, the same sequence of sediments. Okay, so the Cambrian rift to drift sequence is now our valley and ridge province that runs all up the eastern United States, up through about Pennsylvania. where you have limestone covered valleys and sandstone covered hills. The rift basins, rift volcanics, and rifted hunk, and some of the tons of sediments represent our western Blue Ridge province, which is this section in here. Up in Virginia and Maryland, it's only called the Blue Ridge province, not the western Blue Ridge province. Down in Georgia and North Carolina, it's called the western Blue Ridge province. And then there are more provinces to come. That will be in a later video. So go back and rewind this and go over it as many times as you need to. But the cool thing about it is this happened all over the world and all up and down the eastern United States the same way. In the next phase of the geologic history of the eastern United States, which would be the tectonic mountain building event or tectonic orogeny, it is different depending on where you are. It's different. What happened in Georgia is different from what happened in North and South Carolina, which is different from what happened in Virginia and Maryland. So we'll go into that in the next video. Okay, rock buddies, there you have it. The rifting of Supercontinent Rodinia with the rift basins, the igneous volcanics, the faraway rifted hunk, and the tons of sediments, and also the Cambrian explosion and the rifted drift sequence of sandstone, shale, and limestone. Hope this was helpful. If so, please subscribe. Next time, next video, we're going to talk about the tectonic orogeny, tectonic mountain building event. So until then, this is Papa wishing you guys happy rock hunting or happy hunting for whatever you hunt for. Papa out.